Hello everyone. Today we are going to start with a topic called as Telnet, and then we are going to proceed further for the topic SSH, that is nothing but secure shell, and we are going to finalize the module with HTTP browsers. So to begin with, what do we mean by Telnet? A Telnet is an abbreviation for terminal network. Now it is a standard for TCP/IP protocol for virtual terminal services as proposed by the ISO. Now Telnet enables the establishment of a connection to a remote system in such a way that the local terminal appears to be the terminal at the remote system. I repeat, Telnet enables the establishment of a connection to a remote system in such a way that the local terminal appears to be a terminal at the remote system. Telnet is a general purpose client server application program. Telnet is related to several concepts that we are going to briefly describe here. The first and the foremost being a time sharing concept. Now, Telnet was designed at the time when most operating systems such as Unix were operating in time sharing environment. In such an environment, a large computer support multiple users. The interaction between a user and a computer occurs through a terminal, which is usually a combination of keyboard, monitor, and a mouse. Now, in a time sharing environment, even a microcomputer can simulate a terminal with a terminal emulator. Now, in a time sharing environment, all of the processing must be done by the central computer. When a user types a character on the keyboard, the character is usually sent to the computer and echoed to the monitor. Time sharing creates an environment in which each user has the illusion of a dedicated computer. The user can, run a program, access the system resources, switch from one program to another, and so on. The first and the foremost feature is the login feature. Each authorized, in a time sharing environment, users are a part of the system with some right to access resources. Each authorized user has an identification and probably a password. To access the system, the user logs into the system with a user ID or login name. The system also includes checking to prevent an unauthorized user from accessing the resources. The second, concept, the second point is local login. Now, when a user logs into a local time sharing system, it is called a local login. As a user types at a terminal or at a workstation running at a terminal emulator, the keystrokes are accepted by the terminal driver. The terminal driver passes the characters to the operating system. The operating system in turn interprets the combination of characters and invokes the desired application program or utility. It's like you have a simple terminal device over here and it is being given to a terminal driver, which it's like आप एक बड़े सी कंपनी में हो और आप एक पॉइंट पे जाके वहाँ पे कुछ प्रोग्राम एग्जीक्यूट करते हो और मेन प्रोग्राम किसी और स्क्रीन पर रिफ्लेक्ट हो रहा है. इट इज एज सिंपल एज दैट. नाउ the mechanism, however, is not as simple as it seems, because for the operating system may assign special meanings to special character. For example, in Unix, some combination of characters have special meaning, such as the combination of the control character with the character Z, which means suspend. The combination of the control character with the character C, which means abort, and so on. When these special situations do not create any problem in local login, because the terminal emulator and the terminal driver know the exact meaning of each character or combination of characters, they may create problem in remote login. Which process should interpret special characters, the client or the server? We will clarify this situation later. Now, the next part is remote login. When a user wants to access an application, program, or utility located on a remote machine, he or she performs a remote login. Here, the Telnet client, and the server programs come into use. The user sends the keystrokes to a terminal driver, where the local operating system accepts the character but does not interpret them. Now, the characters are sent to the telnet client, which transforms the characters to a universal character set called NVT or network virtual terminal characters and delivers them to the local TCP IP stack, as you can see into the diagram over here, the TCP IP stack. Now the commands or text here in NVT form travel through the internet and arrive at the TCP IP at the remote machine. Here the characters are delivered to the operating system and passed on to the telnet server, which changes the characters to the corresponding what do you say uh, characters understandable by the remote computer. However, the characters cannot be passed directly to the operating system because the remote operating system is not designed to receive characters from a telnet server. It is designed to receive characters from a terminal driver. The solution is to add a piece of software called pseudo terminal driver, which pretends that the characters are coming from a terminal. The operating system then passes these characters to the appropriate application programs. Network virtual what do you say drivers. Here is the diagram which you can see. The terminal is the initial part over here. The data is being sent through to the telnet client, which then converts it into an NVT or the network virtual terminal characters. That NVT characters are sent through the internet towards the telnet server. Then this telnet server passes on that thing to a pseudo terminal driver, which then finally passes on to that specific application program. Now this is what we just said for pseudo terminal driver. Now the next concept, there are several concepts related to that. The next one is symmetry. For symmetry, one interesting feature of telnet is its symmetric option to what do you say negotiate, in which the client and the server are given equal opportunity. Now this means that at the beginning of the connection, it is assumed that both the sides are using a default telnet implementation with no options enabled. If one party wants an option enabled, it can offer or request. The other party has the right to approve the offer or reject the request if the party is not capable of using the option or does not want to use the option. This allows for the expansion of telnet. A client or a server can install a more sophisticated version of telnet with more options. Now when it is connected to a party, it can offer or request these new options. If the other party also supports this option, the options can be enabled, otherwise they are rejected. Now moving to the important concept of SSH, secure shell. What do we mean by secure shell? How is it important? Now this is used basically for remote login application program. Now another population remote login application program is the secure shell, that is nothing that is known by SSH. SSH, like telnet, uses TCP as underlying transport protocol, but SSH is more secure and provides more services than telnet. How? Let's see. First of all, there are two versions of SSH, SSH1 and 2, which are totally incompatible with each other. The first version SSH is now deprecated or discarded or not in use because of security flaws in it. In this section, we discuss only SSH2. Now here you can see the diagram over here. The TCP layer is the transport layer of TCP is over here. Above that you have the application layer, and in that application layer, just above the transport layer, you have a SSH trans. What are its functions? Let's see. Now SSH transport layer protocol or SSH trans over here. Now since TCP is not a secure transport layer protocol, the SSH first uses a protocol that creates a secure channel on the top of what do you say TCP. This new layer is an independent protocol referred to as SSH trans, which is being depicted over here. When the software implementing this protocol is called, the client and the server first use the TCP protocol to establish an insecure pro connection. Now then they exchange several security parameters to establish a secure channel on top of TCP. We'll discuss this later if needed. Now but the services provided by this protocol are: firstly, privacy or confidentiality of the messages exchange, that is one. Data integrity, which means it is guaranteed that the messages exchanged between the client and the server are not changed by an intruder. Server authentication, That is, which means that the client is now sure that the server is the one that it claims to be, and there is no another one faking it. Compression of the messages that improve the efficiency of the system and makes the attack more difficult. These are the features of SSH trans. Now, SSH authentication protocol, SSH auth. Now, after a secure channel is established between a client and the server, uh, between the client and the server is and the server is authenticated for the client. SSH can call another software that can authenticate the client for the server. SSH, what do you say, connection protocol. After the secured channel is established and both server and client are authenticated for each other, SSH can call a piece of software that implements the third protocol, that is nothing but SSH con or SSH connection protocol. One of the services provided by SSH con protocol is to do multiplexing. SSH con takes the secure channel established by two previous protocols, that is TCP SSH trans and SSH auth, uh, by two previous protocols, and lets the client create multiple logical channels over it. The last and not the least, we have SSH applications on the top. Now, after the connection phase is completed, SSH or the secure shell allows several application programs to use the connection. Each application can create a logical channel as described above and then benefit from the secured connection. In other words, remote login is one of the services that can use the SSH con protocol. Other applications such as file transfer application can use one of the logical channels for this purpose. That's for what you say secure shell. It has not been asked in exam, but it is very important for Viva point of view if there is any Viva at the end of this semester. This is the same thing that we just discussed for all the layers and inside the layer details. Now, port forwarding by SSH. What do we mean by that? One of the interesting services provided by SSH protocol is to provide port forwarding. Now, we can use the secured channels available in SSH to access an application program that does not provide security services, such as applications such as Telnet and SMTP. You might have heard SMTP can use the services of SSH using port forwarding mechanism. SSH port forwarding mechanism creates a tunnel through which the messages belonging to other protocol can travel. For this reason, this mechanism is also sometimes referred to as SSH tunneling. Figure shows the concept of port forwarding. Now, we can change direct but insecure what do you say connection between the telnet client and the telnet server by port forwarding. So here this is what do you say for SSH, and now we will be moving forward for what do you say hypertext transfer protocol, that is nothing but HTTP. Now, why is it important? Because today's browser world is completely dependent upon it. HTTP, that you might have heard, and you might be very much familiar with the term HTTP. Now, what is it and how is it so important? Let's see. Now, HTTP, first of all, the hypertext transfer protocol, एक minute, is a protocol which is used mainly to access data on the World Wide Web. Now, it is similar to what do you say FTP or file transfer protocol because it transfers file and uses the services of TCP. However, it is much simpler than FTP because it uses only one TCP connection. That is what is important. Now, here the important part is there is no separate control connection. Only data are transferred between the client and the server. Very much simple enough. The HTTP messages are not destined to be read by humans. They are read and interpreted by the HTTP server and HTTP client. Now, HTTP uses the services of TCP on a well-known port 80. Now, this is what the diagram of an HTTP transaction looks like. It is very much simple in nature. This two what do you say the request message and the response message almost has the same body line. The only difference is here you have a request line, whereas here you have a status line. So now, what are these things? Let us see one by one. Now, in the figure, the HTTP transaction between it illustrates the HTTP transaction between a client and the server. Although HTTP uses the services of TCP, HTTP itself is a stateless protocol, which means that the server does not keep information about the client. One of the best part of HTTP, the client initializes the transaction by sending a request. The server replies by sending a response. Now, first of all, let us see what are the things that we are going to look into the main message. What do we mean by request message? The format of the request message is as shown. A request message consists of a request line, a header, and sometimes a body. Now, what do we have in a request line? The first line in a request message is called a request line. There are three fields in this line separated by some character delimiter. Uh, these fields are called methods, URL, and version. Three important terms. One is method, second is URL, and third is the version. These three should be separated by a space character. At the end of two characters, a carriage return followed by a line feed terminates the line. Now, what are those things? As of now, we don't need to what do you say get into very much detail. Carriage return and line feed मैं आपको बाद में बताऊंगा. Carriage, CARRIAGE, carriage return and line feed, LINE, line feed. Now, uh, now, the second field, that is nothing but the first field was method, the second field is URL. It defines the address and the name of the corresponding web page. The third field, that is nothing but the version, gives the version of the protocol. The most current version of the HTTP is 1.1. Moving on to headers. After the request line, we can have 0 or more request header lines. Each header line sends additional information from the client to the server. For example, the client can request that the document be sent in a special format. Each header line has a header name, a colon, a space, and a header value. Now, moving forward, body in the request message over here. Body in the request message. The body can be present in a request message. Usually, it contains the comment to be sent. Now, the response message. The one of the important things that we need to discuss. The format of the response message is as shown. A response message consists of a status line, a header, a blank line, and sometimes a body. Now, status line, somewhat important over here. The first line in a response message is called as a status line. There are three fields in this line separated by spaces and terminated by carriage return and line feed, as in the previous one. In the initial one, we had what do you say, medium, we had method, we had URL, and then we had a version. In request line, we had three fields. Similarly, in status line, we have three fields, namely, what do you say? Sorry, uh, the three are version, status, code, and phrase. These three important phrase, PHRASE. Now, there are three fields in this line separated by spaces and terminated by a carriage return and line feed. The first line defines the version of the protocol of HTTP, currently 1.1. Second, the status code field defines the status of the request. It consists of three digits, whereas the codes in the range 100 are only informational. The codes in the 200 range indicate a successful request. The code in the 300 range redirect the client to another URL, and the codes in the range 400 indicate an error at the client side. Finally, the codes in the range 500 indicate an error at the server side. The status phrase or the third part explains the status code in the next form. The possible values will be discussed later if needed. Now, header line in response message. After the status line, we have the header line. We can have 0 or more response header. Now, each header line sends additional information from the server to the client. For example, the sender can send extra information about the document. Each header line has a header name, a colon, a space, and a header value. Now, uh, moving on to the body, that is the last part. The body contains the document to be sent from the server to the client. Now, the body is present unless the response is an error message. So that was all for HTTP transaction. This is the thing that we had just discussed for all these things. For example, the request line, headers, body. Similarly, for response message from the server to the client, and so on and so forth. So this ends your HTTP transaction, and this ends your first chapter. So I hope you might have enjoyed the first chapter. Do study, do message me for any doubt that you have, and up till then, stay safe and do study. You might be getting an assignment very soon. Thank you.